Images and image formats. There are many image formats out there, but I just want to concentrate on our 5 most useful for the world of 3D and VFX, starting with the TIFF. TIFF stands for Tagged Image File Format with the extension .tif. They come in 8, 16 or 32 bits per channel. It's very rare you'll come across the 32 bits since they're rather heavy. And RGB or RGBA, which gives us an alpha, which is excellent for our 3D. Used a lot as texture files and a good file to render out from 3D. Here we have an 8-bit TIFF UV test pattern texture, which is square format 1024 1024, and if we look at the channels, red, green and blue. And here we have another TIFF with an alpha. It's just a kind of test render out of Maya, render with an alpha so that we can composite it. So it has a red channel, green, blue, red, green, blue, and the alpha. EXR or OpenEXR with the extension .exr. We mentioned how 32-bit TIFFs can contain a huge amount of information, but the file size becomes unmanageable. So ILM developed the 16-bit floating point EXR and the 32-bit floating point EXR. The 16-bit version has these huge amounts of very accurate data that we require, and is typically an RGBA. What's even much more exciting is the 32-bit version, which supports multi-channels, which means in the old days when we would render out different TIFF images for our different passes, e.g. specular, reflection, diffuse, with the multi-channel version we can render these all into different channels in the same file. So this is being used much more and more for rendering and replacing the TIFF. I am using Adobe Photoshop CS3 here, and I've had to install the plugin Pro EXR. The same is true for CS4. Okay, and it's allowed me to open this FAT EXR or multi-channel EXR. We can see at the top 32-bit. In the channels, pretty usual. RGB, red, green, blue. And the alpha has been shown multiplied by the color channels, giving us this transparency here. What gets very exciting is if we go over to the layers, we have at the top a classical beauty layer, and we have some passes of varying levels of interest and a pass beauty layer. Now this test scene may look dull to you, but these scenes are very useful for testing stuff out. Okay, let's have a look. Let's hide the alleged beauty, and we have the specular pass. Excellent. And if we look at the channels now, we have all the color channels for the specular pass. So let's hide the red and have a look at the blue, green. So we have all the usual available channels for each of the layers that have been rendered. So let's just go through them and have a quick look. Specular, shadow, reflection, diffuse raw, diffuse no shadow, standard diffuse, and more of a proper quality beauty render as well. Now, to you lot new to CG, this might not be all exciting, but if you've spent years rendering out dozens of different TIFFs, each one just giving you the functionality of one of these layers, you might understand how truly excited I am by this. HDR or HDRI images, coming from the term High Dynamic Range Imaging, typically with the extension .HDR, although there are several others in use. They are always 32 bits per channel because they need a large array of information. They are created by combining photographs taken at a large range of exposures from very low to very high, giving a full range of color values which cannot be captured with one image. These can be used for lighting a scene, which is a very good way to start matching your 3D into the real world. We are looking at an HDR image, buildingprobe.hdr from the Paul Debevec website, a 32-bit image, and a bit of a classic. It's in the square kind of spherical format. There's also a lat long horizontal letterbox format and a cross format. Now I've made an 8-bit TIFF version which has clipped the values, so we can look at the differences between this 8-bit TIFF and the 32-bit HDR image. On the left we have our TIFF, select I for the color picker, double click in one of these bright areas and then double click the swatch, and it's showing us brightness of 100% and 255 in the R, red, green and blue. That's equivalent to 1 in more compositing terms. Okay, and then we V select the HDR image, I for color picker, double click the swatch, and we have a completely different window. And this is now showing us values of red 8.466, green 9.7, blue 10.9, etc. And also this 3.8 stops, which is great. Now I want to put some exposure layers on these and bring it down so we can see the detail. I didn't do this before because many of Photoshop's native color adjustments are not done in 32-bit, so it would have obscured some of the information. Layer, new adjustment layer, exposure, and if I bring that down slowly we can see the 8-bit TIFF. It just kind of goes mushy, and we're not seeing any additional information in there, we're just seeing the information available at this exposure but just duller. Okay, I'm going to leave that down at like -6. Now select the HDR image, layer, new adjustment layer, exposure, okay. And now I bring this down and we can see it's completely different when we get down. We're showing up all this additional detailed information which was obscured in the brights. We take it down to the same level, -6, we can see it looks completely different. DPX images, digital picture exchange, extension .dpx, mostly 10 or 16 bits per channel, using a log color space, RGB without an alpha. This file format is used extensively in compositing. The DPX is a descendant of the Cineon file developed by Kodak along with the log color space. These were developed to capture information from the film negatives as they were scanned to be stored on computers. We have a DPX in Photoshop, 16 bits, the classic Kodak digital LAD image using the log color space. Now, it's not designed for being viewed in Photoshop, so we're looking at it in the wrong color space. It's worthwhile you having a look and noticing how bleached out she is. This is classically what happens when you look at a log image in the incorrect color space. Camera raw images. This is not an image format, but a whole class of images containing many formats. 12 or 14 bits of data recorded, but these images need to be processed by a raw converter before they can be viewed and used. Okay, I'm going to bring in this raw image in Photoshop just to have a brief look. Here we have image 36.dng, that stands for digital negative. I produced this from the original CR2 straight from the Canon camera, and I'm going to hit open and we get a dialog box when importing which gives us various controls. Now this is specific to the Canon, but any camera will have a similar setup. You'll be able to alter temperature, tint, exposure, such things, which is extremely useful for us when we want such high amounts of high quality data. And we can choose whether it comes in as 16-bit or 8-bit. Of course we're going to choose 16-bit because we want as much quality as we can get. And these images are great for us to work with doing 3D because they have such a great range of data in them.